Hello, my name is Aihoa, and I will be going over the front end of our real-time drug safety monitoring project. My focus during this project was on maintaining our Trello board and our burn down charts. Here's a quick look at our Trello board. So we have our notes, our backlog, things that we've done, and things that we are currently working on at the time of this video. I also focused on determining if Twitter would be a viable source of data for the project, creating methods to visualize and display our collected data to the public, and putting together the front end of our website. Just to recap, the general idea behind our project was to use publicly available data gathered from social media in order to closely monitor the side effects of drugs, with the end goal being to be able to detect adverse side effects of prescription drugs before they have a major impact on people's lives. So in order to determine if Twitter would be a viable data source for this particular project, we first collected and analyzed past tweets for the top 10 prescribed drugs using this URL command to execute our request. So this just pulls from the API. We have our drug and it returns some tweets for us. We found that while Twitter would be a viable data source, we had to keep in mind that some drugs will not return a sizable amount of data due to various factors such as how long the drug has been on the market, the age group that the drugs are prescribed for, or how quote-unquote socially acceptable the disease or illness is, in order for an individual to willingly create a public post about the drug on social media. So after collecting all of this data, we chose to create word tags and charts to represent our data in a way that would be easily processed and viewed by our audience. Our visualizations are implemented using Google's visualization APIs and JavaScript. So I'm going to jump over to our website and do a quick demo. So here's our website. Say we want to search for Advair. Here, Advair prevents symptoms of asthma or chronic obstructive pulmonary disease. It contains a steroid and long-acting beta agonist. Whoops. So type in Advair and submit word cloud, and we get a cool little word cloud. The size of the terms. It's populated with terms that were pulled from tweets related to Advair. The size of the terms are based on how frequently they occur in our data, and we can go back and query again. So Advair, and we can see the same data, different format. It's a pie chart. We have a nice breakdown of the different symptoms, and we can do the same thing for our bar chart, which also shows number of occurrences of different symptoms. So now I'm going to briefly show you guys the code that was written for our visualizations and our front end. So this is our front end. Here we have links to our style sheets. The CSS is all here, and our HTML is here, and our JavaScript. Then same thing for visualizations. We have links to our style sheets, our CSS to make our site look nice, and all of this is our HTML followed by the JavaScript. So this leads to what I learned working on the project and in the class itself. While I do have experience with agile development, I had no prior experience with the technologies that we worked with for this project. During the project, I was exposed to Spark streaming, which was what we used to scale and stream our data, and I spent a good chunk of time at the onset of our project understanding ZTAKes, the natural language processing system that we use to analyze our collected data. I also worked directly with the Twitter API and experienced firsthand some of its limitations. One of the big ones being that if we were to manually search for tweets, the API would only return a maximum of 100 tweets at a time. Um, Overall, working on the project has taught me a great deal about the architecture of scalable cloud computing applications, and I learned a lot about how an application can process such vast amounts of data and how to build a scalable application that would actually do so.
Hi, my name is King, and today I'll be talking about the backend component of our drug monitoring application for cloud computing. So, let me just turn this down for now. So, my task primarily is to create a database, to interface the database with CTIGs and SparkStream from Xinzhu and Raymond's part, and to push data to the front end by means of doing something. Um, So those are my specifications and my role in this project. So initially, I met up with Raymond, Xinzhu, and discussed what we needed in the database. And we figured that we needed an ID field and a tweet and symptom right here. But we figured out that eventually that all we really needed was ID, drug, symptom, and tweet, because we are literally just going to query. The user would type in a drug, and we would look up in our table for that drug, isolate it, and group all the symptoms together and represent that in a word cloud, in a pie chart, in a bar chart, whatever. Um, so that's what we did in terms of our models. Um, Also, another task that we had to do was to figure out how to make a product for our customer. Um, what we did was I had a lot of experience with Django and Django web development, so we decided to use Django as a way of having something. We use DigitalOcean. It's a provider that spins up VM instances for developers to use, and it spun up a Django instance for us to use, and there we go. So we're using Django to host our application. So you might be wondering how everything works, how our database goes from our backend to the front end. So right now we have this is our server, that's our password. We're going to change it obviously after this. We have code right here that pretty much does what I just mentioned like 30 seconds ago, that groups all the drugs, common drugs together and finds the count. And we have some fun string manipulation to get it in such a way that HTML right over here would understand what it means. So for our draw chart, for our draw chart function, we have a chart that gets passed into it, and that's literally from here. So that's what I'm doing as the person responsible for the back-end to front-end integration. And I know for a fact that Raymond will be talking about how he is constantly pushing data into our database. So there's that too. Also, in the beginning of our project, we were given a GCE instance. So I'm just going to spend the last 30 seconds talking about why we didn't use GCE, which is also leads us to what I personally learned about the project. So GCE works for Django. That I know for sure. Cassandra also works with our project. That I know for sure. But we're choosing DigitalOcean and Postgres because we know for sure this works. GCE doesn't really work that well with Django. I didn't really find enough documentation to fully implement Django in GCE, but I do know for sure that Cassandra works on GCE, and I will show you right now. So this right now is our GCE instance. Let me show you my script. This is my script. Basically, it has all the clusters. It reads it in and it inserts it into our database. And then here is our CQLSH. Here is Cassandra. And I can do something like, see, and as you can see, we have all the tweets being inserted into our Cassandra database in GCE. So everything works. It's just we've been having a lot of troubles getting Django working, and we found it that it works really well in DigitalOcean, so we want to proceed from there. We have DigitalOcean allows us to scale up to 16 gigs. We can install SBT onto DigitalOcean, and we can run SBT, run the Spark stream, run the CTIX there, and we're using that right now as a proof of concept before we can move on with GCE. Obviously, we have a lot of components right now completely implemented on GCE, but it's just we didn't really have the time to completely congeal everything, as opposed to how everything just works in DigitalOcean. So there's that. That's what I learned in terms of my.
Hi, my name is Raymond, and for this component of the cloud project, the drug safety monitoring project, my goal was to generate a script that would take the outputs generated from the Spark streaming application, collecting tweets from Twitter, take those tweets and run the CTIX term analyzer on them, and then store that generated data, including the tweet itself, into the database we have set up. So the main goals I needed to set for myself in order to do this component of the project was first understand the Spark streaming application and the CTIX analyzer and what kind of outputs they generated and how I could take those outputs and capture them with my script to push all that data to the database we have set up on King's DigitalOcean account. So the script here I have generated runs every 3 hours periodically, so as long as the script isn't canceled, it should run to infinity, and it's very simple. Here we have in this line, it just copies the output generated from the Spark streaming application, copies that, and removes that file as well, so that we don't carry over any sort of old tweets. Here we run the CTIX term analyzer on it, on the new tweets.txt file, and then the generated output, this file called datafile.txt, gets pushed to the database very simply after being parsed using line.split. At the end of the script, basically we would delete the datafile.txt and the new tweets.txt, although for the purposes of testing, these were removed so that they just wouldn't be deleted and all that, because we'd like to keep them. And here's the piece of code that says run for 3 hours. And that's pretty much all there is to the script. A few things about the script that we initially tried to do. One was we tried to control the Spark streaming application itself. But from what we learned, once it starts running, you cannot stop it unless you control Z out of it. And additionally, you can only have one Twitter stream at a time per one set of user credentials, as Twitter has limited users to only have a single stream of tweets. And there's only so many search terms you can put into a 15-minute window per query, and that limit is 180. So for future reference, you can only have at most 180 queries if you're trying to pull from Twitter in your Spark streaming application. So while there are thousands of drugs in the world, we're limited to 180 per user account. And here in the terminal, you can see how I run the Python cloud computing script app. There's an error here because of the tweets.txt file, but that can be ignored. And here you can just see the CTIX term analyzer starting up, running, going all the way down. You can see my script working, skipping things that have the drug name pulled out as the symptom, and skipping things that have RT repeated and shows up as a symptom. While this is a symptom in the medical world, since it appears so often in Twitter as retweets, we decided to just eliminate that, as basically that's not very useful data. That's it.
This is Raymond from the Drug Safety Monitoring Group, and my main task is to understand CTAKes and its output and be able to parse that output, rendering it into an easily readable formatted text document in preparation for it to be read into a database. Now, starting with understanding CTAKes and improving its efficiency. This is an older version of the CTAKes term analyzer in which I mainly worked with in order to parse the output and improve its efficiency. You can see here under Analyze, this is where the pipeline is initialized. And this is under the function Analyze, instead of actually being right here just within the object or a class, it's actually within the function. Now, running a few in the very beginning from 1 to 2 words to maybe 10 lines was doing okay. However, when we got to more than a few hundred, then it started lagging very, very badly. The time lag was immense. And therefore, I had to move the initialization upwards, and it took some research on how CTAKes was initialized. But later on, this pipeline is moved upwards, and now the analysis simply resets the text each time, but the pipeline does not change. The pipeline still has to be ran each time with the different identified class, because that's how it's set up. And this is basically down here. You can see this is commented out because this is a backup version, and this is the list of annotations. If you take a look here, that the CTAKes will annotate in the output to determine what the recognized item is. For example, is this a medical frequency? Is it a disease mention, a medical mention, a Roman numeral? Set to false. Set to false because we don't care about Roman numerals. Or a symptom. And this allows us to control, if we need to, what we want from the tweet. Okay, now on to actual parsing. Originally, the output looked like this. Just the medicine, every once in a while something pops up, but it's generally insignificant, which was later on improved here to be able to give out more significant data. You can see that here's asthma, inflammatory asthma. You can see that there's some pulmonary disease mentioned here, weight gain. And this data, however, does not contain the original tweet or structured in a way that's easy to read into a database. So this last version is the most recent code, which now puts the tweet along with this delimiter, the medicine it recognizes, which is the significance from CTAKes, and what CTAKes thinks was significant in reference to the medicine. What I learned while doing this is, first of all, that using Java is very important because Scala does not have basic I/O. It used to, but they took it out later. I do not know why, but the I/O is done with the file writer from Java, using also a string buffer to prevent errors. The second thing I learned is that Scala functional programming comes in very handy at times. For example, here you can see that within the creation, they pass in functions instead of objects. The benefits of using functional programming such as Scala instead of using object-oriented programming is that you can pass functions in. So instead of passing in objects that have states, like for example a Boolean, which might be true or false or even null or ambiguous, instead you simply pass in a function and make the program run it at the same time, which prevented the the item being ambiguous, and you can definitely have an output. And this is very robust and very, very easy for it to avoid many errors that would otherwise pop up. Okay, and that is my part. Thank you.
My project goal is to set up different VMs and port our Spark streaming app in GCE and spin up more VMs based on what we need. I have set up multiple VMs for the demonstration, and each of them have the same development environment. Once we configure one instance successfully, we can just create snapshots like here. And we have snapshot demo, and when we create a new instance, we can just choose what to use. Like we specify the name, zone, and machine type based on there are different types of machine. And we can choose the boot disk based on our own image and snapshot, which is very convenient. Also, we can specify the firewalls. So basically, GCE is allow us to start up one or more virtual computers on Google servers, and you can link multiple virtual computers into your own cluster. So each of them is similar to Node, and we have 4 nodes in our project cloud. You can access each into the virtual machine. Here we can So since our Spark streaming apps is built on SBT, SBT1, and we choose CTX term analyzer. So it begins to load the model. Now we can see that it began to collect data from our Twitter account. I think the problem I have encountered